We're still on our chapter 21, the first section of it, which is our introduction to organic chemistry, and we're going to go a little bit deeper into alkanes today. So in the last lesson we looked at structural isomers, so you should now be able to draw the isomers of butane and pentane, and in this lesson we're going to look at naming them. So over here we have an isomer of butane, so it's C4H10. An isomer of butane. It has the same chemical formula, but it's not 4 carbon atoms all in a row. We've got 3 carbon atoms and we have got 1 carbon atom coming off of that main chain. And what that's called is a branch. So this part is the branch, like the branch of a tree is a small piece coming off of the main trunk of the tree. And so we need to figure out how to name these. So the steps are here, and these are the steps we're going to be following. Now this is a lot of writing on one slide, so I've put all of this on a Word document for you that I'll have in the files section of this chapter. So that'll be there for you to download and to go through along with this. So I would recommend having that up on your screen if you can at the same time, and we'll be going through these steps now together to name a branched alkane. Okay, here I've got a branched hydrocarbon and we need to name it. So the first step that we're going to do is find the longest chain of carbons in the molecule. The number of carbons becomes the prefix for the name. So we're looking for meth, eth, prop, but, pent, all of those. We're trying to figure out which one of those we've got. And so the first thing I want to point out is the most common mistake people make. I've chosen this example deliberately and you'll see why in a second. The most common mistake people make is that they count up the straight chain of carbons and they take that as their answer. So they would say the longest chain here is 5 carbons, and so the root is pent. The name would be pent. And that is incorrect. You should turn the corners to see if you can find a longer chain. So what I mean by that is, what you can do is you can go to each carbon that is at the end of a chain. So this carbon and this carbon that we connected already are at the end of a carbon chain, but so is this one out here, and this is the one people forget. They automatically go from A to B in a straight line and assume that's it, but it's not. So we have the pink line there. The other option for working out which is our carbon chain, you can turn this corner here, or alternatively you could turn this corner. And so if we count those up, the pink line that we did in the beginning is 5 carbons, the red line is 4, but if you look at that purple one, we count 6 carbons on that. So that is your longest chain. So don't be afraid to turn the corners. This is a mistake I see people making all of the time, and so I want you to make sure that you're taking note of that now. You don't just look at the carbon chain that's going straight across. If I gave you, if I told you to measure this line, you wouldn't just measure this part along here because it's the straight part. You would measure this, then the line across, and then you would measure this. So you can turn all those corners to find your longest chain. Hopefully that makes sense. So in this case, our longest chain is 6 carbons, so the root of our name is going to be hex. Step 2 is find the ending of the name by looking at the type of bonding in the molecule, or here we're trying to figure out which homologous series we have. And hopefully you can tell by looking at this, and because we haven't done any other homologous series yet, that this is an alkane. The bonding is all single, so we have a fully saturated molecule. That means the homologous series is an alkane, and the name ending is therefore going to be ANE for the alkane. So now that we know we've got the longest chain named as hexane, we need to be able to name the branch. And the first part of doing that is we need to number our carbon chain. So we know we've got 6 carbons, but which end do we start naming them from or numbering them from? We can do it from either of these carbons, either end of the chain. But what we want to do is we want to make sure this carbon, which is the one with the chain on it, has the lowest number possible. So if we start numbering from this end, that would give that carbon a number of 4, If we start numbering from this end, that would give that carbon a number of 3. So that's the one we're going to go for. So if I start numbering here, you will see that it ends up as a carbon number 3, and that's lower than 4, obviously, so that's the one we would go with. So our carbon chain, our side chain, is on the carbon 3. So next we need to determine the name of the substituent. So how we do that is we figure out how many carbons are in the side chain, and in this case we only have 1. There's 1 carbon in this side chain, and so its name is going to be very similar to how we've named our main carbon chain. So we still have all of the same prefixes. We have meth, eth, prop, bute and pent. All that has changed here is that the name ending is changing to YL. So we have methyl, ethyl, propyl, butyl and pentyl. And so for this one, obviously we only have 1 carbon here, and 1 carbon we know already is meth. We changed the ending to -il, so this is the name of this side chain is methyl. And so step 5 doesn't actually apply here, but I want to show you an example. We put the substituents in alphabetical order. So if we look at this example down here on the right, we have 2 side chains. We have these 2 side chains off of the main chain. And so the first one would be methyl. There is only 1 carbon in that side chain. And the second one is going to be ethyl. And when we are writing these down, they go in front of the parent name. So our one is hexane, so the methyl and ethyl, they would go in front of the hexane. So our name so far is methyl hexane. But this rule is also telling us, or this step, is that to name this one on the right, we would put ethyl before methyl. So it would be ethyl methyl hexane. Next, we need to identify the positions of all the substituents in the name by placing the carbon number where the substituent attaches to the parent chain in front of it. So this is our last step. So we already worked out that the position of the substituent is 1. The name of the substituent is methyl. The number of carbons is hex. And the homologous series is ane, alkane. So our full name for this compound is 3-methylhexane. And just to point out, it's very important that you include between the 3 and the methyl that you put in this little hyphen here. So it's 3-methylhexane. Now I've left some space between those just so you can distinguish the different parts, but that would all be written as one word. So that would be 3-methylhexane, no spaces in between. So we'll go through the example that we had earlier. So step 1 is finding out how many carbons are in your longest chain. And for this one, our longest chain does happen to be the straight chain along the center there. You can count them all up if you want, but that is the longest chain, and that is hept. That has 7 in it. So the name there is going to be hept. And we know that it's an alkane, all single bonds, so it's heptane. Next, we need to number the carbons so that we're giving the substituent the lowest number possible. So we could start numbering from the left or the right here. But if we look at it in terms of which will give these 2 carbons the lowest number possible, we're going to start numbering from the right. Numbering from the right, we have 1, 2, 3, 4, 5, 6, 7. If I was to number the other way, this carbon would end up as 4 still, but this one here would be 5. So that's why we're not doing it that way. So we've given them the shortest number possible. Next, we need to find the names of the substituents. So we named these already. The substituent here has 1 carbon in it, so that's going to be methyl. And the other substituent has 2 carbons in it, So we've got a CH2 and a CH3 here. So we've got 2 carbons, so that means this is going to be ethyl. So what I know now is that this is 3-methyl and this is going to be 4-ethyl. The next step is to put those alphabetically in front of our base name, which we got as hexane. So I'll write that over here. So alphabetically, ethyl comes first, so it's going to be 4-ethyl. We separate it with a hyphen from 3-methyl, and remember it's all one word at the end, so we've got 3-methyl, oh sorry, it should be heptane, and that's the name of this molecule. So the next example we're going to look at is when we have 2 branches again, but this time they're identical. So starting off the naming of this, I can see that I've got 4 carbons, so my name is going to be bute, and I can see that it's an alkane, so I've got butane there in my longest chain along here. Next I'm going to look at my substituents. The number of carbon that they're on, we can number these either way. It's going to be 2, 3, or either way, it doesn't matter. So this is my 2-methyl, and the other one is 3-methyl down here. And the next thing is putting those in front of butane. So both of these are the same alphabetically because they are the same substance. So it's going to be methyl butane either way. But how do we approach this when we've got 2 identical branches? Do we have to say 2-methyl, 3-methyl butane? The answer is no. We can summarize this a little bit easier. What we can do is we can write down the numbers they're on, 2, 3, and then because it's 2 methyl groups we use our prefix of di. So remember, mono is 1, di is 2, tri is 3. They're the only ones you would need to know. And because we've got 2 methyl groups here, it's dimethyl. So you can number them in the beginning by separating the 2 numbers with a comma. Then it's our hyphen dimethyl. So the full name of that one here is 2,3-dimethyl butane. The next one we're going to look at is similar. It's an isomer of the 2,3-dimethyl butane. These are isomers of each other. And again, you can see here we've got the same length carbon chain, so that's going to be butane again. And for our side chains, this is methyl, this is methyl. So we've got 2 methyl groups again. So we know that it's going to be dimethyl. And now we just need to work out the numbers. So we need to number it again, starting with the carbon closest to the side chains. So that would be from this side, 1, 2, 3, 4. So they are both on number 2. So I would name it the exact same way as I did with the other one, but this time it will just be 2,2-dimethyl butane. And that's the final name for that one. Okay, so the next one we're going to look at is a carbon chain with 3 side chains. I don't know why that little red line is there, but we'll get past it. So this is about as complex as it would get. So step 1 is finding the longest carbon chain. So you can pause here and do that for yourself. Otherwise, I'm just going to carry on. So the longest carbon chain would be this one here. That's 5 carbons in the chain. So I know that's going to be pent, and it is an alkane, all single bonds. So my ending is going to be ane. Now, just to point out here, there is another option going from this carbon up here all the way down to this one. That would give me 5 carbons in my main chain as well. However, that just looks a bit more complicated, so I'm going to stick with the chain going across. Again, it won't always be the one going straight across, so you need to be able to look through them all. The next is looking at my side chains. So my side chains here are methyl, I'm just going to write M, methyl and methyl. So that's 3 methyl groups. So if you remember from the last slide, we had mono, di and tri that you need to know. Mono is 1, di is 2, tri is 3. So hopefully it makes sense to you that this one is going to have trimethyl in the name. So it's going to be trimethylpentane. Now the last thing we need to do is number these side chains. So numbering the main chain, we could start from the left or the right. I'm going to start from the left and I'll explain to you why now. So if we look at that, we have got our methyl groups that are on carbon 2. We've got 2 of those. So both of those have the lowest number possible, and we've got a carbon or a side chain on carbon 4 as well. If we were to number it the other way around, which is totally possible as well, we would start 1, 2, 3, 4, 5, and we would see that we would only have one carbon or one side chain on carbon 2, and we would have 2 side chains that have the number 4, which isn't kind of following the rule of giving them the lowest number possible. So we're going to stick with the numbering in red there, because we'll have 2 carbons or 2 side chains on carbon 2 and 1 on carbon 4, as opposed to the other way around. So for this one, we've got 2 carbons on carbon 2, so that'll be 2, 2, and we've got a side chain on carbon 4, so it'll be 2, 2, 4 dash trimethylpentane, and that's the final name for this molecule. It's an isomer of octane, and it is also known as isooctane. So isomer of octane, isooctane. And the reason I chose this example as one for you to do is that you'll see it again later on in chapter 21 when we're talking about fuels. This last one, I'm going to let you pause it, and I want you to go through the answer yourself and then come back to it, and I'll pop the answer up on the screen in a second.